Okay, so for topic 3, we're going to be talking about scientific notation, which is a different way to write really large and small numbers. Okay, so the first concept is talking about extremely large numbers. In science, it's common to look at these really large numbers. So if we're looking at the following number, 3, 6, 9, 12, 15, 18, 21, 24, with 25 digits. It says this number is the number of particles found in 12 grams of carbon-12. Okay, so really large number. We could also talk about really small numbers. Water H2O will split into H plus and OH minus one time in 10 million molecules at random. It's represented by the fraction over here, which is also this decimal. So what we want to do is come up with a shorthand way to write these really large or really small numbers. So the steps for writing in scientific notation are, it says here, first find the first significant digit. And all a significant digit is a number where it is between 1 and 10. So it can be 1, it can be anywhere between 1 and 10, it can't be 10. So it's between 1 and 10. And then you write a decimal after this first digit, so you just write a decimal point. And then you count the decimal places. Multiply by an appropriate power of 10 that represents all the decimal places moved. Drop all the trailing zeros, rounding to an appropriate decimal place. Okay, so if we wanted to write for example, the number 5,100,000,000 in scientific notation, we would have to first find the first significant digit, which is going to take place right here with the 5. And we're going to write it as 5 points, decimal points, 1. Drop all the trailing zeros so I don't have to write all the other zeros. And here's the part that's always the same. It's the times 10 part, but we have to tell it how many places to move. So the times 10 part will always tell you how many spots to move. So what I do is I kind of either visually or in my head find where that significant digit starts and then count my way over. 1, 2, 3, 4, 5, 6, 7, 8, until I get to the end, in this case 9. So I know it's 5.1 times 10 to the 9th power. Another way to look at it for large numbers at least is this number as a whole has 10 digits. Since I placed my decimal point one spot after the first digit, right here, I'd be able to just say times 10 to the 9th, because that's one less digit than what we started with. So you can count the loops, or you can count the number of digits initially to help you figure out this. Second one, so this one's going to be 6.021. So notice I got to include all the other significant digits here. Times 10 to the, well, I know it's a 6-digit thing, so that should be 5 power. Okay, and then let's look at a small number. This is a little different. We still have to find the first significant digit, which is after 3 here. So we put a decimal point there, and then we count backwards until the original decimal point. 1, 2, 3, 4. This one's a little harder to just figure out by the number of digits, so I would try the loop method for this one. So that's going to be an answer of 3.2 times 10 to the, now because we're going to the left as opposed to the right, left is negative, I'm going to give it a negative exponent, -4. So large numbers get positive exponents, small numbers get negative exponents.